Heaven and I'm with MyLee, and today we're going to show you how to calculate a regression line. So today for our equation we have two variables, age for x and height for y. We believe these two are related. So we're going to calculate the regression line for y hat using age to predict height. So for our x we have a sample of 5. For our x it's 12, 14, 17, 18, and 20. And for our y it's 68, 65, 63, 70, and 72. So for our x, we're going to sum our sample. So 12 plus 14 plus 17 plus 18 plus 20 equals 81 divided by our sample, which is 5, and our mean equals 16.2. And for y, 68 plus 65 plus 63 plus 70 plus 72, which is 338, divided by our sample, which is 5, which gives us 67.6. So now that we got our mean of x, which is 16.2, I'm going to put it in our chart. So we put 16.2 here. And for our mean of y, it's 67.6. And now I'm going to solve for the standard deviations of x and y. So this is, and so we have, for our x column, it's negative 4.2, negative 2.2, 3.8, and this one is 0.4, negative 2.6, negative 4.6, 2.4, 4.4, and for us, this should equal 0. We're going to square both of these items, and now we're going to be focusing on solving for Sx and Sy. So for this column, we get 17.64, 4.84, 0.64, 3.24, 14.44, and our sum for this column is 40.8. And for yi minus y bar, it's going to be 0.16, 6.76, 21.16, 5.76, and 19.36. And for our sum for this column would be 53.2. So now for our equation, we're going to do Sx equals the square root of our sum of xi minus x bar squared divided by our sample size minus 1. So we get Sx equals the square root of 40.8 divided by 4, which gives us 3.19. So I'm going to plug that in our column and do the same for Sy equals the square root of 53.2 divided by 4, which gives us 3.64, and I'm going to plug that one into our column right here.
Now I'm going to be solving for covariance, but first let's put the equation on the board. So the covariance equation is going to be the sum of xi minus x bar times yi minus y bar all over n minus 1, n being our sample size. So first, like Heaven did before, I'm going to rewrite the column. So it's going to be xi minus x bar. Then we're going to do yi minus y bar. And then we're going to multiply those together. But we already solved this in the last problem, so I'll just rewrite the answers. So in this column we got, so it was negative 4.2, we got negative 2.2, then we got 0.8, we have 1.8, and 3.8. For the y column, this is before we squared it, we have 0.4, then we have negative 2.6, I have negative 4.6, then I have 2.4 and 4.4. So now we're going to multiply these across to get this column. So negative 4.2 times 0.4, we have negative 1.68. This times this, it's going to be 5.72. Two negatives make a positive, and then I'll just fill in the rest. So then we have negative 3.68. I have a positive 4.32, and then 16.72. So this portion is this portion of our covariance equation, but we have to sum them all. So the sum of this is 21.4. So now we can plug this into the equation. So I'll bring it down here. So I have covariance equals 21.4 all over n minus 1. N is 4. Sorry, n is 5 because our population is 5. So 5 minus 1 is 4. So we're going to do 21.4 divided by 4. And then we're going to get 5.35. So I'll put this and fill it into the box. So our covariance is 5.35. Okay, so now continue. We have to find R before we can find B or A. So let's write out our equation that we're looking for anyway. We're solving for the regression line equation. So we'll do y hat equals A plus BX. This is the equation we're looking for. So in order to find R, we'll use this equation. So R equals the covariance of x and y, which is what we found earlier, and then we're going to divide that by the standard deviation of x and the standard deviation of y. And we also found those two, so they're right here. So what I'm going to do, I'll just plug it in. So I have R equals 5.35 divided by Sx, which is 16. Oh, sorry, that's the mean. Sx is 3.19 times 3.64, I'll get an R of 0.46. So this is our R, so I'll fill it in here. Okay, so now that we found R, we can find B. So this is the equation for B. We have B equals the standard deviation of y over the standard deviation of x times R. And we have all of these elements. So B equals Sy, which is 3.64 over 3.19 times R, which is 0.46, and we'll get a B that equals 0.52. Okay, so I'll just write that in this. Now we have to solve for A. So since we've solved for B, we can find A, because the equation for A is this. I'll come over here for this one. So A equals the mean of y minus B times the mean of x. So we have all these elements again, so I'll do A equals mean of y, 67.6 minus B, we just solved for that, so that's 0.52 times the mean of x, which is 16.2. Okay, so then A equals, we got 59.176. So I'll fill that in here, 59.176. Okay, so the last step to solving for the regression line is just to plug it into the equation. So I'll do it right here. So we have our regression line is equal to A, which is 59. So we'll round it off. I'll say 59.2. 59.2 plus B, and our B is 0.52 times X. So this is our regression line equation.